This lecture is about solving equations that contain absolute value signs. So to start out, let's talk about what is an absolute value. So we'll start with the formal definition. So the absolute value of, let's say, x is its magnitude. That might be a word you've heard before. Or in other words, its distance from 0 on the number line. And so, just as a notation, we write the absolute value of x this way, with two straight lines, very tall straight lines, to make sure we don't confuse them with ones. So, if we think about what this looks like, here's 0. If x is positive, this distance is the absolute value of x. If x is negative, this distance is the absolute value of x. So what patterns do we notice? Well, we notice, first of all, because absolute value is a distance, it's always positive. That's a key idea here. And so in particular, we'll notice that if x is positive, then the absolute value of x is just x. And we notice if x is negative, then the absolute value of x has to be negative x, because the negative of a negative would be positive. Or if we wanted to write the same thing mathematically, we could write it this way. The absolute value of x is equal to x if x is greater than or equal to 0, and negative x if x is less than 0. This is just repeating in math, right here, what we've already said in words, right here. So, why do we need absolute value? Why are we interested in it? Well, the short answer to that is that there are a lot of real-life situations where we can use absolute value to model something, where it can represent a distance or a magnitude that can only be positive. So, for example, we might have something where we're just interested in how far apart two things are, two cars, for example. We can have equations, C1 and C2, that represent where the cars are in space. And so if we wrote C1 minus C2, this would be the distance between the two cars. But the problem is that could be positive or negative, and if we're really just interested in how far apart they are, we're just interested in a positive value. So really, to calculate the distance between these two things, we'd want to take the absolute value. That's one example. And so there are lots of other examples. If we're really just interested in how far apart certain things might be, we might be interested in taking the absolute value of something in order to make sure that we only get positive values. Another example might be as if we're actually measuring something. So maybe we have an equation that represents the relationship between some physical things. For example, let's suppose I'm building a cube or a rectangular three-dimensional object. If I've got some equation that tells me how long the side should be to get the area or the volume that I want, then if I solve that equation to figure out how long the sides can be and I get a negative value, I know that that doesn't make sense. So basically, anytime we're looking at distances and we want them to be positive, we may need to use absolute value in a particular way. So the next question is, how do we solve absolute value equations? We already know how to solve linear equations. We know how to solve quadratic equations. We have a lot of principles that tell us what we can do to both sides of an equation. So how much of that can we use when we're trying to solve absolute value equations? Well, let's think about this for a moment. If I have an equation with an absolute value sign in it, and I want to solve for x, let's say, for example, then I'm going to need to get x by itself on one side. So if x is somewhere inside that absolute value sign, I'm going to need to find a way to rewrite the equation without the absolute value sign so that I can move x around, as it were. So how could we possibly get rid of an absolute value sign? What we really mean when we ask this is, how can we replace the equation with an absolute value in it with another equation or set of equations that don't contain absolute value signs? And they have to be equivalent to have the same solution set, right? So in other words, how can we replace an absolute value equation with equivalent equations that don't have an absolute value sign. Well, let's think about this. If we have the absolute value of A equals B for some algebraic expressions A and B, and of course where we must have B is greater than or equal to 0, because an absolute value, the answer to an absolute value equation must always be positive, so it wouldn't make any sense to have B be anything that's negative. Then we can rewrite it as A equals B, or A equals negative B. So this is equivalent to this. The absolute value equation should have the same solution set as this pair of non-absolute value equations. And note, as I stated, we must have B is greater than or equal to 0 because an absolute value can never, by definition, be negative. What if we have something a little more complicated, though? That last example just had absolute value of A equals B, but what if we had two absolute value signs? If we have absolute value of one thing with the absolute value of another. So, what does that actually mean? The absolute value of A equals the absolute value of B. Well, it means either A and B have the same sign, or they have opposite signs. Because it's saying that everything about A and B are the same except for perhaps the sign, because all the absolute value can do to something is to change the sign. So, we have the same sign, we get A equals B, or A and B have opposite signs. In which case, A equals negative B, or you could just as easily write B equals negative A. Basically the same thing. So, in this case, if we had the absolute value of A equals the absolute value of B, we can rewrite it as A equals B, or A equals negative B. So let's try to use these ideas to try to solve some absolute value problems. Let's take a look at them. examples. Number 1. The absolute value of a equals 2.5, and we would like to solve for a. Well, we begin simply by rewriting this. We know if the absolute value of a equals 2.5, we know that either a equals 2.5 or a equals negative 2.5, because the only thing that absolute value sign will do is to change a negative to a positive, or to leave a positive as a positive. And actually, this is already solved for a, so that's our solution right there. We have two possible values for a. And in fact, the absolute value of 2.5 is 2.5. The absolute value of negative 2.5 is also positive 2.5. So we can think about plugging that in to make sure that it works in the original equation. Here's another one. Negative 3 equals the absolute value of y. Solve for y. Well, we have to be careful. Some people are tempted here to try to do what we just did in the previous problem, but notice we can't do that. We cannot, in this case, rewrite this. Why is that? It's because this equation has set the absolute value equal to something negative. So we can't get rid of the absolute value sign, because we can't rewrite that as y equals positive 3 or negative 3. Because, think about that, if we were to plug it in, if we plugged in positive 3 for y, we would never get an absolute value of negative 3. And we plugged in negative 3 for y, we'd never get an absolute value of negative 3. So there's nothing we can plug in for y to make this equation true. So the answer in this particular case is actually that there is no solution. The solution set is empty. Which you may sometimes see written just like that, as an empty set. And why is that true? Because by definition an absolute value is always positive, so it can never be equal to negative 3. Let's look at our next example. We have 9 equals the absolute value of 3 minus 2b, and we'd like to solve for b. Well, we take our first steps by rewriting it without the absolute value, if possible, and that is possible because this 9 is positive. So we can rewrite this as the 9 is equal to 3 minus 2b, or negative 9 is equal to 3 minus 2b. This makes sense. If we think about it, what does the absolute value do? All it does is take away any negative signs if they're there. So if 3 minus 2b is positive, it should be equal to positive 9 in order for us to take an absolute value and get a 9. Or if 3 minus 2b is negative, it should be equal to negative 9, because that's the only thing we can take the absolute value of and get 9. So now we have our two equations, and we just solve using the techniques we already know. So on the left here, I want to subtract 3 from both sides, so we get 6 equals negative 2b. I'm going to divide both sides by negative 2. And so now I get negative 3 is equal to b. So that's one possible solution. Now if I do the same thing on the other side, I want to subtract 3 from both sides. I'm going to get negative 9 minus 3 is negative 12 equals negative 2b. And then again I want to divide both sides by negative 2 to get the b by itself. And so I get 6 equals b. Here are my two possible values, negative 3 and 6. I should check them. Again, just as with any problem where I've solved for a variable, it's a good idea to check by plugging back in again. So I have 9 is equal to the absolute value of 3 minus 2 times b. So I start by plugging in the negative 3 value, and that gets me 9 is equal to the absolute value of 3 negative 2 times negative 3 is positive 6, so I get 3 plus 6. So I get 9 is equal to the absolute value of 9, and that's certainly true. Let's look at the second example. 9 equals the absolute value of 3 minus 2 times b. And this, in this second case, I got 6 for b, so let's plug that in. So I get 9 equals the absolute value of 3 minus 2 times 6 is 12. 9 equals 3 minus 12 is negative 9. And 9, in fact, equals the absolute value of negative 9. So we can see that that's correct. We can see that both of our answers work in this case. Let's do a few more. Here's another example. The absolute value of x minus 7 equals the absolute value of 2x minus 1. And we want to solve for x. So in this case, I just remember that if I have this absolute value and that absolute value are equal to each other, it means that basically they have to have the same magnitude on each side. It's just the sign that might be different. So it's possible that we have x minus 7 equals 2x minus 1. That would certainly make the equation true. But it's also possible that we have x minus 7 is equal to negative 2x minus 1. Now be careful. Note that I had to make the whole thing negative here. The whole side must be made negative. You have to be careful not to accidentally just put the negative sign in front of one part of it. Okay, so now we can proceed. Now we have two equations. We just need to solve each individual equation the way we always have been. So over on the left, I might subtract x from both sides. So we'll get negative 7 is equal to x minus 1. I'll add 1 to both sides. So we'll get negative 6 is equal to x. So that's one possible solution. 4. Over here, similar thing. Let's distribute the negative sign to both pieces. So I get x minus 7 equals negative 2x plus 1. Now I can add 2x to both sides. So we get 3x minus 7 equals 1. Add 7 to both sides. I get 3x equals 8. And now divide both sides by 3. And I get x equals 8/3. Now again, I should check these. So I have x minus 7 is equal to 2x minus 1 when I take the absolute value of each side. So if I plug in negative 6, which was my first solution, let's see if that works. Negative 6 minus 7 is negative 13, the absolute value of that. 2 times negative 6 is negative 12 minus 1. So I get the absolute value of negative 13 is equal to the absolute value of negative 13. That's certainly true. Let's check the second possibility. So again, I have the absolute value of x minus 7 on one side and the absolute value of 2x minus 1 on the other side. And now I'm going to plug in 8/3. So 8/3 minus 7, I'm going to need to put 7 over 1 to turn into a fraction, and multiply on the top and the bottom by 3 to get a common denominator. So I will get that the absolute value of 8/3 minus 7 times 3 is 21/3. Here, similarly, I could put the 2 over 1. 8 times 2 is 16/3, just inside the absolute value sign, minus 1 I could change to 1 over 1, and multiply the top and the bottom by 3 to get a common denominator, so we get 3/3. So what I get here is 8/3 minus 21/3. Well, that's going to be a negative in there. So I just have to ask what is 21 minus 8. That's going to be 13. So I get negative 13/3 is equal to 16/3 minus 3/3 is 13/3. And we can see that this is definitely the case because the absolute value of 13/3 is just 13/3, and the absolute value of positive 13/3 is just 13/3. So this is equal. So we've checked both of these and we've seen that both of them work out. A few more examples. What if we have 3x minus 7, taking the absolute value of that, is equal to the absolute value of 1 minus 3x. In this case, again, we're solving for x. Well, again, if these two absolute values are equal, it means that this and this have to either be exactly the same thing, or they need to just have opposite signs. So I can rewrite this as 3x minus 7 equals 1 minus 3x, or 3x minus 7 equals negative, and then the whole thing again, 1 minus 3x. I have to be sure I remember to make the whole thing negative. Okay, so now I can go ahead and solve using the traditional techniques. I can subtract 3x on both sides. And I will get negative 7 equals 1 minus 6x. Now I can subtract 1 from each side. Now we'll get negative 8 equals negative 6x. And I can divide both sides by negative 6. So I get 4/3 equals x. That's one possible solution. Now let's try the other side. I need to distribute the negative sign to both pieces. So we get 3x minus 7 equals negative 1 plus 3x. I can subtract 3x on both sides, in which case I get negative 7 equals negative 1. But this is not true. So this part has no solution. So in this case, we only have one solution. Even though we often have two solutions to absolute value problems, we only have one solution here. And in fact, we should check this solution to be sure. So again, we started out with the absolute value of 3 times x minus 7 equals the absolute value of 1 minus 3 times x. And we need to plug in 4/3, which is what we got for our answer. So we can change everything into fractions here. 3 over 1 times 4 over 3. And we notice that the 3 on top and the 3 on the bottom can both be divided by 3 to get 1 over 1 minus 7 equals 1 minus 3 over 1 times 4 over 3. Again, the same thing. We divide the top and the bottom by 3 to get 1 in each spot. So now we have 1 over 1 times 4 over 1 equals 4 minus 7. 1 minus 1 over 1 times 4 over 1 is 4. And so we get 4 minus 7 is negative 3. And we get 1 minus 4 is negative 3. And of course, the absolute value of negative 3 does equal the absolute value of negative 3. We just get 3 equals 3. So that's correct. So we've checked our solution there. Let's do one last problem. What if we have the absolute value of y minus 8 equals the absolute value of 8 minus y? And we want to solve for y. Well, again, I'm just going on the basic principle that if the absolute value of these two quantities is equal, then either those two quantities are equal or they're opposites. So either they have the same sign or they have the opposite sign. So either we have y minus 8 equals 8 minus y, or we have y minus 8 equals negative 8 minus y. And again, we need to make the whole thing negative. Now we go about solving each problem here. So y minus 8 equals 8 minus y. I'm just going to subtract y from both sides. Y minus y equals 0. So we get negative 8 equals 8 minus 2y. We can subtract 8 from both sides. So we get negative 16 equals negative 2y. And we can divide both sides by negative 2. So we get negative 16 divided by negative 2 is positive 8 equals y. That's one possible solution. Or, what do we get if we do this side? Well, we need to distribute the negative sign to both sides. So we get y minus 8 equals negative 8 plus y, because minus a negative y is plus a y. And then we'll need to subtract y from both sides to get y on one side. Y minus y is 0, so we get negative 8 equals y minus y is 0, so we get negative 8 equals negative 8. This is always true So the solution set here all real numbers. It doesn't matter what we plug in for y here. Anything we plug in for y into this equation will work, because no matter what y is, we're still going to end up with negative 8 equals negative 8, which is always true. So what's our final answer here? Well, we could say y equals 8 or all real numbers, but since 8 is a real number, all real numbers is our answer. The solution set is a set of all real numbers. And we can see why that might be true. If we look back at the original question, what is this really saying? The distance between y and 8, right? Y minus 8 is the difference between y and 8, and taking the absolute value is really just giving us the distance between y and 8. 8 minus y, and then taking the absolute value, is again just giving us the distance between y and 8. So those two distances are clearly always going to be the same, no matter what y is. So now we can see that we know how to solve any equation that has an absolute value sign in it, because all we need to do is use the definition of the absolute value to rewrite the absolute value equation as a set of equations that don't contain absolute value signs. And we can do that because as long as the absolute value equation is something that has a solution, as long as it's not something where we're trying to say that the absolute value is a negative value, which is impossible, we can always rewrite an absolute value equation as another set of equivalent equations that don't have absolute value signs. And once we've done that, all we need to do is use the techniques we already know to solve the equations.